Now we're in section 7.4 and we're going to go over the graph and equations of a hyperbola. So here we have a horizontal hyperbola, and you'll see that the first fraction in that equation has the x values in the numerator, and then we have a vertical hyperbola, and you can see the fraction that appears first has the y values in the numerator. And we also have these a's and these b's. So the a will be the distance from the center to a vertex, and the b value will be the distance from the center to, you can see kind of this rectangle pictured. This rectangle will be a useful guide for us to help us to graph the asymptotes more quickly. And then we have another relationship up here in the formulas, b squared equals c squared minus a squared. I'm going to write it down here because we'll need it for the next problem. The c value is the distance from the center to a focus. Okay? So just to let you know that this rectangle has dimensions 2a by 2b. And then we will always use this rectangle to help us to draw the asymptotes in, because the asymptotes, as you can see, just pass through the diagonals of this rectangle. So let's try an example. Find the center, find the equation of the hyperbola and graph with the center at 1, 4, focus negative 2, 4, vertex 0, 4. I'm going to go ahead and start graphing first. So I have the center 1, 4, that's h comma k. So let's plot that point. 2, 4. I also have a focus at negative 2, 4. So that focus is 3 units away from the center. That's telling me the c value already is 3, and that another focus will appear 3 units on the other side. Okay, the vertex, which actually is a point that lies on the hyperbola, is 0, 4. That vertex is 1 unit away from the center. That gives me my a value. My a value is 1. And it also tells me there's another vertex on the other side of the center that's also 1 unit away. I can now take this a value and c value to find the b value. The point of finding the b value is so you can draw in that rectangle to help you fill in your asymptotes. Okay, so let's go ahead and use this relationship here. B squared equals c squared minus a squared. I also do need the b value to fill in my equation. So b squared equals 9 minus 1. So b squared equals 8. So b equals the square root of 8, which is 2 square root 2, which is about 2.8, and I'm noting the approximation for the graph. So let's talk about the equation first, and we'll focus on finishing up the graph. So I can tell by this relationship over here that my transverse axis is horizontal. So I'm looking at a horizontal hyperbola. So a hyperbola of this form. X minus h squared over a squared minus y minus k squared over b squared equals 1. So I have my h value, it is 1. So x minus 1 squared over a squared is 1 minus y minus 4 squared over b squared, which is 8, equals 1. So this is the equation of the hyperbola. Now I want to use the b value to draw in my rectangle. So if I go to the center and I go up 2.8 units, 1, 2, about to here, and down 2.8 units, 1, 2, so down to here, I can draw in a rectangle. The rectangle isn't officially part of the graph of the hyperbola. It's just there as a guide to help me to accurately sketch in my asymptotes. So the asymptotes should go through the diagonal of the rectangle we just drew. So it will look like this. And other asymptote here. Okay. And remember that asymptotes tell you what the graph's approaching. So I'm going to have kind of this wide looking hyperbola here as I fill in the branches. So your hyperbola should never cross your asymptotes, right? It's just going to approach them. Okay, so let's try another example. This one we've been given two vertices and we've been given the equation of one asymptote. Okay, so let's go ahead and plot the points we were given, the vertices. We've been given both, which will tell us the center. The center will lie directly in between those. So I have 1, -3 is one vertex, and 1, 1 is another vertex. Okay, let's label them. So the center should lie directly between those two vertices. So the center will be here. So let's write that down. So the center is the point 1, -1. So this is H and this is K. It also tells me my A value. My A value must be 2. A is the distance from the center to a vertex. And then you'll note that the A value appears right here in the equation of the asymptote. This is now our B value. Okay, that relationship is also shown in the table above. We can also see the center appearing here. We have H, K. So it's all kind of coming together. So the B value is 3. Remember, I can use that B value to help me to draw in my rectangle. So if I go 3 units to the left and to the right of the center, I can use that to draw in this rectangle, which will help me to draw in my asymptotes. Okay, so the asymptotes go through the diagonals of the rectangle. So something like that. Looks okay. Same for the other diagonal. So it looks something like this. And then I can use that to guide my branches for my hyperbola. So there's like a really wide hyperbola here. Okay, and I fill it in down here as well. Oops, it shouldn't cross over the asymptote. I'm gonna redraw that. Okay, and lastly, let's put everything together into the equation. This is a vertical hyperbola, so I know that this is the form of the equation. The y minus k squared comes first, over a squared minus x minus h squared over b squared equals 1. Okay, so k is -1, so I have y plus 1 squared over a squared. A was 2, so a squared is 4, minus x minus h, so x minus 1 squared over b squared, which is 9, equals to 1. So that is the final equation for that one. This next example is slightly different. This time we are seeing the graph of a hyperbola, and we are asked to find the equation. This one's quite simple because you can see that it's centered at the origin. So the center is the point 0, 0. So that's pretty nice. H and K are both 0, 0. They're both 0. Oops, not X. H and K. So you can see from the picture that this is a horizontal hyperbola. So it's going to be x squared over something minus y squared over something equals 1. So the A value should be the distance from the center to a vertex. It looks like that is 4 units. So A is 4. So it should be x squared over 16. The B value would be the distance from the center to the other side of this rectangle here. So it looks like B is 3. So B squared is 9. You can also see the A's and B's reflected in the slope of the asymptote. In this next example, we can see that the equation is not in standard form. So to put it in standard form, we will need to complete the square for both the x and y terms. So similar strategy to the one above. Let's rewrite it, grouping the terms together. So I'm going to put the y terms together first, 2y squared plus 8y. Then I'll put the x terms together, minus x squared plus 2x. And then the 3 I'll subtract to get it to the other side. So I want to complete the square for both of these, but I will need to factor out those leading coefficients first. So I'll factor out the 2. And I'll leave a blank here to complete the square for the y's. I'll factor out the minus sign. And I'll leave a blank here as well. Now let's complete the square for both of them. So y squared plus 4y should be plus 4, right? B over 2 squared. 4 over 2 squared is 4. That 4 will be multiplied by the 8 though, so what we actually added was 8, so we'll add that to the other side as well. Inside the parentheses here, I'm going to add b over 2 squared. Negative 2 over 2 squared is positive 1, but it's actually a minus 1, so a minus 1 over here as well. So we completed the squares so that we'd be able to factor. So now I can factor these. They're both going to be perfect square trinomials. There we go. So now they're factored. Negative 3 plus 8 is 5, minus 1 is 4. So the last step to get this into standard form would be to get 1 on this side by dividing everything by 4. So I'll reduce the fractions. 2/4 would be 1/2. This one, nothing to reduce with. Okay, so now we have it in standard form. You can see that the y fraction comes first. This is going to be a vertical hyperbola. I can go ahead and already graph the center. Let's write some stuff off to the side over here. So we know the center. The center is the point 1, negative 2. So I'll plot it right here. The distance from the center to the vertices will be a. We have right here that a squared is equal to 2. So a is the square root of 2, which is about 1.4. So I can use that to plot my vertices, which should be above and below. So here is here's a vertex here. Here's the vertex here. So the 1.4 units away from the center. The b value I can see is 2. The b value I can use to graph my rectangle, which I'll do next. Okay, looks something like this. And the rectangle can help me to guide my asymptotes. The asymptotes are going to go through the diagonal of the rectangle, so something like this. Get these asymptotes drawn in here. Okay, so now we can go ahead and kind of draw a picture here of what the hyperbola looks like. Okay, so we were asked to find a few things. Find the center, transverse axis, vertices, foci, and asymptotes. So we can answer a few of those things right now. The vertices are a distance of square root of 2 above and below the center. So let's write those in. So above and below, so we'll take the y value and we'll add and subtract the square root of 2. So that's kind of a quick and easy way to express the vertices. The foci, we'll need to find that c value, so we'll wait on that. The asymptotes, okay, so I'm just using the structure that was given in the formula above. So let's write this out, asymptotes. So y minus k, so y plus 2 equals plus or minus a over b, so square root 2 over 2, x minus h, so x minus 1. So that gives me the equations of the asymptotes. I still need to find the c value so I can list the foci out. So let's solve for c. So here's a relationship. B squared equals c squared minus a squared. B squared is 4. Then we have c squared we don't know. A squared is 2. So c squared equals to 6. So c is the square root of 6, which is about 2.4. I can use the 2.4 to kind of draw in the foci. So one focus is up here, the other one is down here. I can use the square root of 6 to actually write out the coordinates of the foci. So the foci are square root 6 units above and below the center. So notice the x value for all these points is 1. That's not changing. The y value is. So it's negative 2 plus or minus the square root of 6. And by the way, the fact that the x value is 1 for all of these kind of gives me a hint for my transverse axis. It is a vertical line, and it is the line x equals 1. So the transverse axis passes through the center, the vertices, and the foci. Now that we have 3 conic sections, One important thing will be to know the difference between them. So hopefully you're seeing how the formulas are slightly different from each other. So for this first one, we can tell right away it only has one square term, which means it must be a parabola. It is already in standard form. And just by looking at this equation, I can tell that it's going to be horizontal and that it's going to face left. So it's a parabola that looks something like that. Okay, now in the next one, I'm seeing both x squared and y squared, but I am seeing a minus. This tells me right away that this is a hyperbola. Remember, for a hyperbola, there is a subtraction in front of one of the x squared or y squared terms. To put it in standard form, I will have to complete the square. So let me gather up terms here. So I'll gather up the x terms first, then the y terms, and then I'll add the 88. Add 88 to both sides here to move the constant over. Then we do have to factor out to make the leading coefficient 1 in order to complete the square, leaving a space here, factoring out a minus sign for the y terms, leaving a space here. Now I can complete the square inside the parentheses, so here I'll add 1, but I actually added a 9 because we have a factor of 9 right here. Here I'm adding 16. Actually, it's being subtracted, so I'll take that into account over here as well. So now I can factor these as perfect square trinomials. And then I have 88 plus 9, it's 97 minus 16, 81. Okay, and lastly, to get this into standard form, I need a 1 on this side, so I'll divide everything by 81. On the left, we can reduce 9 over 81 will be 9. So I have x minus 1 squared over, I shouldn't say 9, I should say 1/9, so over 9, minus y plus 4 squared over 81. So because the x fraction comes first, this would be a horizontal hyperbola. It would look something like this. Okay, one more. Here I'm seeing x squared terms and y squared terms. They are both positive, which indicates right away that it is an ellipse. So we'll do a similar thing to the last example to put it in standard form. I will collect my x terms together and my y terms together. And I will move over any constant term. However, I need to do that. I need to subtract the 541. Okay, so I do need to factor out this 36 here. So I have x squared minus 2x, I'll leave a blank. The leading coefficient there was already 1, so there was no factoring necessary. For the y terms, I need to factor out a 36. So I get y squared plus 8y, I'll leave a blank to complete the square, equals negative 541. Now let's go ahead and complete the square inside the parentheses. So for the first one, I'll add 1, and I'll make sure I add 1 to both sides. For the next one, I'll have to add, let's see, b over 2 squared. 8 over 2 squared is 4 squared, so 16. 16 times 36, I wrote it down over here, is 576. Okay, now we can factor. So I have x minus 1 squared plus 36 times y plus 4 squared equals negative 541 plus 1 is negative 540 plus 576 is 36. So lastly, we can divide here. So everything's getting divided by 36. So nothing to reduce on this first term. X minus 1 squared over 36 plus, it'll be y plus 4 squared over 1, or you can just leave it as y plus 4 squared equals 1. So because larger number is underneath the